Hello and welcome to this lecture on project evaluation and control. We have talked in the past about the importance of choosing the right projects based on organizational goals and opportunities and so forth. Once you've chosen your projects, you still have to manage your projects, but you also still have to evaluate and control the projects. How likely is the project to end up over budget? How much over budget? How likely is the project to end up missing its deadlines? How much over the deadlines? Being able to give good answers to these kinds of questions is what this chapter is about. In our chapter outline, there will be 4 things that we'll be talking about in our lecture today. That third point, earned value management, will be the focus of what we're talking about, and it actually has even some subpoints in your book. I think there's more than these 4 in your book, but I'm going to roll all of the earned value management into a single large third point in this lecture. Okay, our first point is about control cycles. All models of organizational control have usually these 4 elements that continually repeat. First is setting the goal, the project baseline, the plan. And then second is having a system to measure the ongoing status. And there's a lot of possibilities for this measuring. That's what we'll be looking at, some different techniques in this chapter. Third is to then, once you have a plan and a method to measure progress on that plan, you can compare the two and you look for gaps between the plan or the goal and the analysis or performance. And you want to address those the gaps depending on how large the gap is between the plan and the performance. 4 is to take a corrective action. Now, it may be minor for small gaps, it may be major for large gaps, and then this process repeats. It's not a one-time thing, it's a continual activity as part of project evaluation and control. So what are some different measuring progress systems that we can use? Well, let's look at this, some ways of monitoring our project performance. There are 3 common tools and methods that we talk about in this chapter. Our author talks about the project S-curve, milestone analysis, and Gantt chart, and a specific type of Gantt chart that we'll see in a second. So first of all, the project S-curve model. The idea behind this S-curve is that it is a very common form that most projects have this shape when you map cost against time, when you plot cost against time. And what we see is that the cost is increasing at a slow rate early on, and then the increase goes more heavy in the middle. That's when we're on the tall part of the S. Cost is rising very quickly over time. And then near the end of the project, cost is still going up, of course. We're still spending time, money, effort on our project, but the rate of the cost is going down. So really there's some ramp up time, there's some heavy work time, and then there's some ramp down time, and that gives us this classic S-curve. And a project has this classic S-curve. So you can use this as a model. It's very simplistic, but it gives you a way of kind of tracking how you're going. So we can have our actual costs, and this project, is scheduled to be 50 weeks long, but we're actually only finished up our 25th week here. And we can see that the actual cost, in this drawing it's on red dashed line, the actual cost is less than the S-curve budgeted cost. So there is a negative variance in this case. The word negative is in the sense of spending negative. We've actually spent less than we've budgeted. So it's a good kind of negative. We have more money in reserve. So there's a negative variance there. And so it's a very simple approach that we can use. You can track your expenses and anticipate them following this S-curve. Now, some drawbacks is that even though this can alert you to positive or negative variances, it really doesn't tell you anything about why we have this. So we've got this $10,000 negative variance. We spent $10,000 less than we would have expected. Well, we don't know why that is. We don't know if there's been some efficiencies involved. We don't know if there's been a key person has not started billing the project because they haven't even started their project yet and they should be working already. So even though it is a tool to kind of give us a heads up, it really is an incomplete tool, and we're going to find, in fact, that all three of these tools in this second part are incomplete. For example, the second one of these, the milestone analysis, is another method for monitoring project progress. Milestones are events or stages of the project that represent significant accomplishments. These are, the big deals, big tent poles along the way. The advantages of milestones, the reason that they are worth paying attention to, is they show completion of important steps. They can motivate the team. We've accomplished something. We don't feel like we're just coming in, working in the mines every day and not making any progress. Milestones allow us to see progress, can be motivating. They give reevaluation points. It's a natural time to step back and say, okay, do we still want to keep on with this project? Is it still achieving our goals? Has anything changed outside of this project that needs to affect what we're doing? It is a signal for team and suppliers. It's a great way to help coordinate with your third-party vendors, with your suppliers, so that we're starting this. Once we hit this milestone, then we're going to need all of your widgets, all of your gizmos are going to need to be in our warehouse on this date. So they are good for coordinating with suppliers. They identify key review gates. So if you're on some kind of a large government project, there's some natural review dates involved, and milestones make sense for those, even if they're perhaps arbitrary. We need a July 1st report for large government projects in particular, or any kind of very large projects like that. They might have some key review dates. They help coordinate team members' schedules. So again, you have more than likely individuals that are working on your project or working on other projects when they're not working with you, if you're not a full-time person for this project. And knowing what those milestones are can help coordinate that as well. And they delineate work packages. One of the main problems with the milestones method is that it's really a reactive control system. You must first achieve the milestone and then evaluate those milestones relative to your goals. If there's any problems, you don't know about them early. In fact, you might not receive any progress reports to indicate problems up until the point that the bad news is made available not only to you but to people outside your group, and possibly even made available to the public. So these are, well, it's a common and an easy thing to do. It's also a little reactive, as opposed to sensing problems before they happen and being able to take more proactive steps. And there's a special type, the third of our three models we're looking at, is the a Gantt chart that has a special tracking feature, so a tracking Gantt chart. And what you see on this Gantt chart, we've got 1, 2, 3, 4, 5 tasks, and of those tasks, there's percentages associated with these tasks. It's a percentage complete, and it's even filled in. So that first one is 100% complete, and you'll see that there is a solid bar in there. It's 100% complete. This next one is 61% complete, and 61% of the bar is filled in, and the remaining 39% is not filled in. 82% complete with 18% not filled in, and then 0% on those last few tasks. So it gives us all the advantages of a Gantt chart, with the extra information of being able to track elements in our project and see a visual summary of this. So the key benefit of this is that it's easy to understand because of its visual nature. The weakness of a tracking Gantt chart is, again, it doesn't identify the underlying source of the problems. What caused the slippage? It's also difficult to use these to make future projections. Being a little ahead or a little behind when you don't know why makes it very difficult to make future projections. So as we move into the bulk of what we're talking about in this chapter, and where we're going to spend a few more minutes in our lecture here, is with earned value management. And the idea of EVMs is that we're addressing the weaknesses of an S-curve model, which focuses on time and cost, and the mapping of time and cost is where we get that S-curve. And it also, but it doesn't address performance at all, so we don't really know how well we're doing. We just have that curve. Or we look at the control charts for the Gantt chart, or the milestones, where we're looking at time and performance, but we're not really bringing cost into play. We may be on budget, but if we've doubled our budget to we've on time, but if we've doubled our spending to get there, that would be an alert, and that doesn't get factored in on either the milestone or the Gantt chart. So what we need is something new and different and better, and that's where the earned value management model comes in. An EVM is sometimes called the golden triangle method, because it addresses time and cost and performance in one model. And I think once you see how this works, you'll appreciate that it's an elegant and reasonable approach here. So in the book, there's a lot of terms that come at you. My recommendation is we start with the most important here, this idea of earned value. We're talking about the earned value management, so it makes sense that earned value would be something we'd start with. And the idea of earned value is that work is value. We've done some work, and that work has value to us. So what we're really measuring is how much work has been accomplished to the date. So what has been our earned value to date? And we can see in the book they have this table that shows a project layout. We've got broken up in 5-week durations, and we have design, engineer, install, test, total. So we have design, engineer, install, test. We have 4 categories there, and then there's a total and a cumulative total for our budget area. And this area right here is what we have budgeted when the project begins. So we've gone through and we've decided that we're going to, in week 5, after 5 weeks, we will have spent $1,000, if those are $1,000 is what that might represent. We spent $6,000 designing at the end of week 5, and at the end of week 10, we've spent an additional $2,000 more on design work, and we've spent $4,000 on engineering, and we've spent so that gives us another $6,000 in the total area for after week 10, and our cumulative total is 12. And what you'll see is that that's just our standard budget breakdown. That those numbers are fixed unless we go back and revise the budget. But the idea is that's our budget. We're above budget or below budget, or ahead of schedule or behind schedule. Those numbers are all fixed. What we have in the EVM model that's kind of neat and extra here is this notion of percent complete. Now, once we've set up our budget but we haven't started working on it, everything is going to be 0% complete. Nothing has been done. Once we're completely finished and we've delivered the product and we've wrapped up everything and we're totally finished, the percent complete should be 100% on each and every task in our project. But from the time we very begin until the time we very end, the percent complete on each and every task is going to be anything between 0 and 100%. So at a moment in time, we have a percent complete for each of those tasks. And that percent complete is what we use to determine our earned value. And the earned value is simply the percent complete times the task total budgeted. So design, in this table 3 here, we see that design is 8 times 100%. Well, the 100% is the 100% from for that task. Engineering is 100%, install is 50, and testing is 0. So 100, 150, 0. That's where the percent complete is coming from. Those are the numbers that are reported how we are making progress on this project. Where did the 8, 28, 30, and 14 come from? Well, that's the sum of design. All the design budgeted is 6 plus 2, 8. All the engineering budgeted is 4 plus 8 plus 8 plus 8. That's 8, 16, 24 plus 4, 28. That's where we get 28. All of the install that's budgeted is 4 plus 20 plus 6. that's 30, and we see 30 here. And testing is 2 plus 6 plus 4 plus 2, that's 14, 14. So that's where those numbers are coming from. Per item, the total budgeted for throughout the entire project for the item times what percentage of that item is reported as being complete at this point. That's how we get our earned value. So real quick, here's a sample problem. Use the data to calculate the earned value for the project. All amounts are in thousands of dollars. So what we have here is a diagram that shows us a project with conceptual design, graphic design, copyright, staples, tooling, and production. So we have 6 tasks, a total per week, and then a cumulative total across the bottom. And then we have our week 5, week 10, week 15, week 20, week 25. And then in thousands of dollars, $10,000, $6,000, $12,000 are there in the middle, and our percent complete. So let's do this. Let's do a quick little Excel demo here. Let's see if we can pull up Excel. And so I can see my screen space better. I don't know if you know this little trick, but they're in the ribbon version of Office. If you have Office 2007, 2010, there's this little arrow icon near the upper right that will allow you to hide and show the ribbon. And since I don't want that space there, I want the screen real estate, I'm going to hide this so that I can type my information in here a little bit easier. So I've got my duration here. I've got week 5, week 10, week 15, week 20, and week 25. So there's my duration. And I've got task 1, task 2, task 3, task 4, task 5, and task 6. Total and cum total. Okay, so my budget, according to this, let me type these numbers in. I've got 10 here, 6 and 12. At week 15, it's 64462, and on week 20, it is 45296, and week 25 is a 6 and a 4. Okay, so if I've done that right, open a 14 there. So if I've done this right, I can confirm my numbers. So my weekly totals should be 10, 18, 22, 26, and 24, and they are. And then my cumulative totals are the week total, and then this week's total. The cumulative total is both of those weeks together. Cumulative total is all these weeks together. All these weeks together, and one more. All these weeks together. Okay, so I've got my information in there, and what I see, sorry about that. So it happens to be $100,000 is what this project is. So that's a nice round number. This project budgets out to be $100,000, 25 weeks of work, and $100,000. That's our budget coming in. Now we have in this chart, going back to our problem, use the data to calculate the earned value for the project. The earned value is not based on any time window, it's just based on how much complete do we have. So we've got a percent complete here, and we're 100% complete with task 1, we're 100% complete with task 2, 100% complete with task 3, 70% with task 4, 50% task 5, and task 6 is at 20%. So that's how much we have completed on each of these tasks. Task 1, task 2, task 3, and I can do the earned value. The earned value is 16 times 100%. That's going to be 16. And this is, the sum of those is 22 times 100%. And so that's going to be a 22. And I know the sum of those is 15 times, that's going to be a 15. But you know, it's a little harder to say that's 6. What's 70% of 6? And I'm not real sure what that is off the top of my head. Or I'm not sure what 20% of 22 is. I could make a pretty good guess at that, but I'm going to take advantage of the power of Excel. So I'm going to say I'll let Excel add up those week values for me, and then I'll multiply that by my percent complete. So 16, which is what we knew that answer was. We know this one is going to be 22. We know that one's going to be 15. So there's no surprises there. But if I want to know what 70% of that value is, it's 4.2, 50%, and that last one there, 20% of that of the task 6. So I add all those totals up, and this value 71.1, that is my EV, my earned value. Okay, so 71.1, $71,000, that is the earned value in this case. And we see that that is in fact what we expected to get, 71.1. And remember, these numbers represent dollars here. We're talking about the budget, the money we're spending, assuming we're getting value back for our money. It's the money we're spending in to get the equivalent value back, $71,100. Here's a second problem that's going to use the earned value and something more than that. And this one's asking a different question. This one says at the end of week 20, this project from the figure shown has a cost of $79,000 and has earned value as indicated in the table. So I can use the table to figure out my earned value, which is what I just got through doing. And in fact, I think these may be the same numbers that we used before, so we get to use our same 71.1 earned value. Use the data to calculate the cost performance index for this project. And again, these are dollar amounts in thousands. So if I want to do cost performance index, with the EVM model, cost performance index is going to be my earned value, which we already know how to calculate that, divided by something called the actual cost of the work performed cumulatively to date. And they're telling us, in this case, we don't have to calculate, they're telling us the project has cost $79,000, right? At the end of week 20, at this point in time, we've actually the actual cost for work performed cumulatively to date right now is $79,000. So I know the AC and I know the EV, the earned value, because I just got through calculating 71.1 a second ago. So I can do my math here. I can plug this into Excel to confirm those numbers, because I don't, off the top of my head, know that calculation is correct, but I know the 71.1 is correct. We know that 79 was given to us as the actual cost cumulative to date, what we've done so far. So I'm going to say the EV, earned value, divided by the AC, the actual cost cumulative to date, that is going to be 0.9. And that is in fact what we see as our cost performance index, EV divided by AC. Now what does that tell us? The cool thing about that is we can then use that cost index, cost performance index value, to figure out how much do we think this project is going to come out. Now the fact that this is less than 1, the fact that this cost of 0.9 is our cost performance index, means that we're not getting $1 of value for every dollar we're spending. The value we're getting is less than what we have budgeted. Assuming that we budget correctly, for every dollar we spend we're getting $1 value back. That's not the case right now. Our cost performance index is less than 1, and that means we're going to end up having to spend more money. Your cost performance index, if things are good, your cost performance index will be 1 point something. Right? If your project's really good, it might be 2 point something. You end up, coming in half budget or something. So this number tells us something, and what it's telling us, because it's less than 1, it's telling us that we're not getting good value on our money right now. It means we're going to end up having to spend more money when we're done. But we don't just say, yeah, the budget's high. We can actually use this number and get a specific value. We can take the inverse, 1 divided by the cost performance index, and multiply that by whatever we have budgeted in our fixed budget before we got started, and that will give us a revised estimate. So 1 divided by 1.9 times, remember the budget was $100,000 is what this cumulative budget was when we added all those up. So multiply 1 over the cost performance index, the inverse cost performance index, times the budget, and we end up with 111 point something. And that means that we now estimate, our best estimate now is that the project it's actually going to end up costing $111,000 total, rather than the $100,000 we thought it was going to cost when we started out. One more problem here, one more sample problem. We're going to look at something different here. Use the data to calculate the schedule performance index, right? Not cost performance index, but schedule or time performance index for the project at the end of week 20. So here we know that we've got our data here. We can use this data to calculate the earned value, because the earned value is just based on the budget and the percentages completed so far. But we're looking at a specific time window. So we're assuming these percent completions are right now time 20, and we're looking at week 20, and we want to figure out our schedule performance index. Schedule performance index is the earned value divided by the planned value. Now, what is the planned value? The planned value comes from the budget. Going back to table 2, remember that red box we highlighted, these are our budgeted costs. They're not changing, they're fixed before we begin. And we may end up saying we're over budget or ahead of budget or over time or whatever, but that's our budget we're basing it from. In this budget, there is across the bottom cumulative totals over time for our expenditures. Those are the planned values. The planned values are the cumulative costs from the budget over time. So, getting back to our problem, I know that I need the planned values, and in this figure, the cumulative budgeted cost over time I have highlighted in blue now. And at the end of week 20, I know that PV value, the planned value from the budget, is 76, which represents $76,000. That's what we had planned for that value there. The earned value, because my percentages are different, I have to plug in new different percentages here. So let me go ahead and do that here real quick. I can pull up Excel again. Whoops. That wasn't what I expected to do. There we go. So my dates are the same. I still have the same budget windows there, right? 10 and 6, and then 12, 6, 4, and 4, 5, 6. So all of those are the same, and I can even see that my cumulative totals are the same, right? 10, 28, 50, 76. But what's different here is my percent completes. 100%, 100%, 60%. So this is 60%. And then 100%, and then 50 and 20. So those are my percent completes, and that changes my earned value. So now we're saying that at the time window 20, these are the percentages, and therefore there's the earned value at time window 20. And I know that is the planned value at time window 20. So I can calculate earned value divided by the planned value. I can make a calculation there for what this index is going to be. 0.88. Okay. And sure enough, that's what we see. So we've got our earned value, our new earned value. And just to pull that back up, we can confirm here. Our new earned value is 66.9. We know the 76. That's not a calculated value. It's calculated in the budget. It has nothing to do with our percentages at time 20, because that's what the problem states. And we know that the schedule performance index is earned value divided by planned value. So we get 0.88. And then from there, again, this is something that allows us to make a prediction on the schedule. We can again do an inverse of the index value times the schedule to come up with a result. So 1 over 0.88 times our schedule. And if you remember our schedule, and I've got it there on the screen smaller there, this original budget was 25 weeks. So the 1 over the index times 25 weeks, 28.4. That means we now estimate the project will actually take 28.4 weeks total to be completed. And as before, as this index value is less than 1, it means that we're getting less than a week's worth of value for a week's worth of money we had budgeted. So the cool thing about earned value management model is that we get to look at both cost and time, and we can make predictions about our final budget cost and our final delivery time on our project using these numbers. So those two calculations, the cost performance index EV over AC and the schedule performance index EV over PV, the earned value over actual cost and earned value over planned value, can help us. So the actual cost has to do with the cost axis. So we budgeted a certain amount, and then our actual cost may be higher, and in that case we're spending more than we want to, right? So that represents overspending. At the same time, we can look at the present value versus the earned value, the actual work accomplished. And if it's if that's going further on our time schedule, then we're getting to the point that if it's taking us longer to do that, then there's a slip that direction as well. So the point here is that we're looking at both the cost axis and the schedule axis with one model, and that's very, very, very powerful for us. And we get to make predictions based on those, not just tracking based on those. Our book does talk about managing portfolios as opposed to a single project with the earned value management model, and basically just means that for each and every one of the projects in your portfolio, you have to have these earned value measures. And if you can do that, then you can scale up or extend what we do on a single project across all the projects in your portfolio. The last thing to talk about on the EVM approach is the fact that those percentages, we didn't really say where did those percentages come from. So there I've got my chart there, and I've got the percentages highlighted in purple here on the screen. Where did that 100, 100, 100, 70, 50, 20, where did that come from? Well, those percentages are actually the critical part of the earned value model, because those are what we use to calculate the earned value, and then the earned value we use to calculate everything else. So how do we get accurate and up-to-date information in our earned value model? How do we do it? That's really critical to what we're doing. And there's a couple of approaches that are interesting that you can use. One is a 0-100 rule. The idea behind a 0-100 rule is that the percentage is 0 until it's finished. So just because you've been working on it, that doesn't change the percentage. When you complete it, it switches immediately to 100. Until it's complete, it's at 0. That is unambiguous. It's very clear that the right value is recorded there. Are you done with the project? Yes or no. If you are, it's 100. If you're not, it's 0. But it really only kind of works with activities that have very short durations, 1 or 2 days, I think it says in the book. It needs to be a short duration project. It can't be building a house. It can't be, designing a new piece of software. It can't be if your schedule is at a very, very short window of opportunity, like 2 days max, then you could use that 0-1%, because in the meantime between those, it wouldn't really, okay, we're 50% complete on a project that I'm going to be done with at 5 p.m. today. I don't need to have that level of granularity. But if it's something that's going to take a week to be done, and I've spent 4 days out of 5 days on a week, but it still shows up as 0 because I'm not complete yet, then the 0-100 rule wouldn't work very well. Something that's a little more accurate than the 0-100 rule is the 50-50 rule. And the idea here is that you assign 0 for the task until it gets started. As soon as you start it, it jumps to 50%, and it stays at 50% until you finish. And again, it doesn't matter if you're 1 hour into it or 1 hour away from being done, you're 50% in the transition from I've started the project until I've completed the project. So that gives you a little more leeway if you have projects that are just slightly bigger than what would work in the 0-100 rule. But again, anytime you get into any steps, any tasks that have some significant size, you're probably not going to be able to use either one of those approaches. You're probably going to want to use a percentage complete rule, and that requires the manager and the individuals doing the tasks having an honest appraisal of the ongoing activities based on whatever percentage is being completed. It's not based on how much money you've spent. It's not based on how much time is budgeted. It's based on how are we actually doing on getting a percentage of this complete. And one thing to consider as we do this, there is it makes a difference, and this figure is in your book, and it's a good little example. Column 1, these are the percentages that were just assigned using percentage complete. in consultation between the project manager and the individuals doing the individual tasks. We got percentages of 100, 80, 60, 33, 25, 0, and 0. Okay, so that's the percentage complete at this moment in time on this particular project. And taking those percentages and running through the process that we just got through running through ourselves, we can make an estimate that this project is going to be done. The project lifetime is going to be 16.28 months, and it's going to cost $210,000 to complete. Now, without changing anything other than these percentages, rounding these percentages to a 0, 50, 100 model. So instead of doing the prediction, we're going to say our percentages have to be 0, 50, or 100. So 100 rounds to 100, of course. 80 is closer to 100 than it is to 50, so 80 rounds to 100. 60 is closer to 50 than anything else, so it rounds to 50. 33 is closer to 50. 25 is right there on the edge. You could have gone either way, but probably round up. 25 becomes 50. So we've just taken those same percentages and we've mapped them to a 0, 50, or 100 option. And doing so said, oh yeah, this project that was going to take 16 months, what I really meant is it's going to take just a little over a year. It's going to be done in 12 months. And I said it was going to be $210,000. What I really meant is it's going to be $163,000. That's a pretty big difference. I think you have to admit that's a pretty big difference on explaining what's going on here, when the only thing that's we've done is we've gone from percentages, these percentage values, to these 0, 50, or 100 percentage values, a 50-50 model. More than likely these tasks are a little too broad to do that 50-50 model. And if we did something a little bit bigger, instead of the complete freedom that we have for 100 different values, we say 0, 25, 50, 75, 100. So we're still going to ballpark a quarter of the way, halfway, 3/4 of the way done, or completely finished. Going back to our original 80, 80 maps closest to 75, 60 maps closest to 50 of our choices, 0, 25, 50, 75, and 100. 33 maps closest to 25, 25, 25, 0, 0. This gives us something that's actually more expensive and longer than what we had originally. So it's the point that getting accurate percentages is going to have follow-up effects, is going to have rippling effects on your prediction, is very important when you're doing this kind of model. Okay, so I said that was going to be where we spent the bulk of our time. Let's just wrap up real quick with this last little bit talking about human factors. Whenever I start talking about here's a formula, here's a model, here's how we can predict and manage and do things, I'm always leery, because I don't want to suggest that people can be taken out of this process. We don't want to treat people like machines. There are still significant human factors involved. And good project managers are good people managers, and you can't. I strongly encourage you to never forget that in anything you're doing. Never take a person for granted. Whether it's the person that's serving you food at McDonald's, whether it's the person that's driving the bus you're riding, or whatever they're doing, don't take people for granted. And certainly not people that you work with and people that you manage. You must take into account human factors. And this table just shows some of the success and failure factors from a human perspective. Personal ambition, top management support, team motivation, clear objectives, technological advantages. These are all traits, human factors that can have positive effects. Team motivation, personal motivation, technical expertise, client support, financial support. These are all human elements that can contribute to your success. At the same time, if you've got an unmotivated team, you've got poor leadership, you've got funding problems, You've got I don't see it in this list on the right there, but you're misreporting your estimates. Oh, we think it's going to cost us $60,000 for this project, and really you only think it's going to be $40,000, but you're inflating the numbers for personal reasons and so on. There's a large number of those things we've talked about in our book previously that can be human factors in a negative way. Also in this last little bit in our book, when you read this, it talks about some critical success factors, and again, it's just a litany of all the things that mean you can't be dogmatic in thinking, well, I've plugged the numbers into my spreadsheet, so I know exactly what's going to happen. You don't know what's going to happen tomorrow. You don't know what's going to happen this afternoon. There's always a sense of awe and wonder when we're dealing with human beings. Good motivation, keeping everybody on track, remembering what we're trying to do, going back to the original goal, getting everybody to pull in the same direction, getting everybody to give their very best out of a sense of a mutual pride in what you're doing is going to be key to your success. And you can read this in your book. This isn't something I make a big deal of here, because I think the the part we talked about before, the actual calculations, being able to make future projections, is more important here. But they do talk, the project mission. Again, that's the underlying purpose, and that is very important. You want to know what we're working on. That's when it comes to human management, being a good people person. Keeping that common vision is so important there. Top management support. We've talked about that before, that it's important to have your project champions, to have your top management support as you're going through projects, and so on. So these elements, I think, are a nice counterweight to the idea of we can mathematically plug numbers into spreadsheets and come up with predictions on how long things are going to do and how much it's going to cost. But if anywhere along the line you start losing your people, then it doesn't matter what your spreadsheets say. Your project is going to struggle to be a success. Okay, thank you. Have a very good day.